A warm welcome, please, for Mr. Rahul Deshpande.
How's everyone doing? Good? It's 2:45, so that's about the time the food hits your gut in the small intestine now. So, the enzymes are working, the blood is now not in the brain, it's right there. It's a good time to talk about security. Is it right? All right. So I'm going to talk about security. All right. I work for MasterCard. My name is Rahul Deshpande. I work for MasterCard. MasterCard, as you know, is a big company, as you can see. We're in 210 countries. We accept 150 currencies. Last year, we did 38.6 billion processed transactions to about $4.1 trillion of total volume. So why I'm showing you that is because I just want to prove that we know payments. What I'm going to do is I'm going to walk you through how a payment transaction works and some of the security mechanisms that are in place within the network that would help you to make your site, WooCommerce site, to be secure and also have less fraud. So let's dive right into how the payment transaction works. So you may have heard about four-party payment system. That's what typically what happens when you're running a payment transaction. There are four parties that are involved in a transaction. So you have merchant, who is the one who is accepting the payment. You have the customer, who is offering a credit card number or a debit card number. You have the merchant bank, which works with the merchants, and then you have issuing bank, which works with the customer. So here's how a transaction works. So you say you're on WooCommerce, your customer is on a WooCommerce site, and you're accepting a payment. The payment goes through a payment gateway, which ultimately goes to a merchant bank. The merchant bank then sends that transaction to MasterCard, if it's a MasterCard. The MasterCard then looks at the card and then looks at the BIN number, which is the first 6 digits of your credit card number, and finds out who the issuer bank is. And then MasterCard then sends that to the issuing bank. The issuing bank then looks at your credits, the customer's credit limit. If he has credit limit, then issues that the transaction is now approved. MasterCard then returns that result to merchant bank, which then goes to the payment gateway, which then ultimately goes to your customer. Oh, wow, okay. Once again. So that's how a typical transaction works. Now, there are too many steps, but we do these steps in about 130 milliseconds. That's the fastest network that we have for MasterCard. So I'm going to talk about a few different areas within this ecosystem. I'm going to talk about transaction security between your website and the payment gateway. I'm going to then talk about the tokenization, which happens between the merchant bank or the payment gateway and from your website. And then I'm going to briefly touch upon the velocity checks and AVS CVC checks that happen on the back end. All right, so let's go straight into how transaction works, right? So your server typically talks to a payment provider, and nowadays it uses a REST protocol. Now, as you know, REST is built on HTTP. So when HTTP, and it uses something called a basic auth, right? So how does it work? So say your customer is now accessing, or you're accessing a protected resource on a server. And since that resource is protected, the server responds back with a 401 access denied. And then it says, hey, you need to use a basic auth. Then he responds back a username and password, and it gets sent as a GET request, and thus you get access to that particular resource. So that's how a basic auth works. So now for REST, someone found out that, hey, instead of using the username and password, which happens to be just a string, right? It's a string which is concatenated with a colon. Why not just use a key? And that's the concept of an API key, right? So you're just passing a user ID. Instead of user ID, you're passing this big, long API key. So that's how today's authentication works typically for REST. So what happens is, you have a secret key on a client, which happens to be an API key. You are sending the payload along with the key from the client to the server, which is your payment gateway on SSL. On the server side, that key is now verified, and then that payload that gets transacted, right? So that's how a typical transaction works. Now, you're passing that data over a network, and you're using SSL. So you think it's going to be secure. So let's go into details about how SSL works. So you may have seen this in your prior life. If you're a computer science student, this is networking 101. There are 7 abstract layers of networking, right? When a data gets passed through a network, it gets passed through all these layers. So your application layer is your browser layer, your session layer is your database layer, your transport layer is your TCP/IP, and the physical layer is your cables. So all these layers, the data gets passed through. Now, SSL is something called TLS. TLS is transport level security. So what that means is, at the transport layer, your data is going to be encrypted. So here's an example of a GET request. So as you can see on the left-hand side, that's how the GET request looks. At the transport layer, if you look at it, the only information that is really visible is rahuldeshpande.net, which happens to be my URL. But everything else is encrypted. So at the transport layer, your data is perfectly protected. But what happens on the layers above? You have 3 layers above, right? So on the presentation layer, your data is still visible because the data is decrypted at that time. So for example, in browser history, I can see a GET request right there, which is decrypted right now. Same thing happens on the server side. In a server log, an access log, your information is visible. So what I'm saying to you is sending the data, sending the keys, sending your user ID and password on SSL may not be enough when you're talking about your server security, and that's how most of the hackers get access to your information. So is there a better way? And the better way is using signatures. So instead of sending the data, actually, the user ID password, what we do, or what the signature method does, is you sign a payload with a unique signature, secret key, and then you pass on the signature back to the server. So on the server side, what you do is you separate out the payload, you sign with the secret key that you have, and then you verify the signature. And you achieve the same effect as of a user ID and password, right? So this is a better way of doing things. Now your user ID, password, your keys never really pass the network. So there's a method called JWS, which is pretty easy. It's JSON web signature. We use that with Simplify Commerce, which is our platform. And we are encouraging everyone to use JWS when you're using REST security. So all it does is just signs the payload. So that's a better way to protect your transaction. The second thing I'm going to talk about is PCI exposure. So here's how a typical transaction works from your customer, a browser, to your website, to the server, to the payment gateway. So the customer presses a button, presses submit button, and sends credit card information to the website, which is a server. And then the server sends that information, merely forwards that information to the payment gateway, right? And that's how typically the process works. The problem with that is now you're handling the credit card information. Even if you're not storing it, you're still handling the information. Your network is still handling the information. Because of that, you're going to be at a higher level of PCI security. So you don't want to do that, right? So you don't want to handle the security, because if you do, then you can't use shared services, because now your server needs to be an island. It needs to be protected. So instead of that, the better way is to use tokenization. So instead of the customer submitting the credit card information to your server, if you have a JavaScript that, one of the things that we do is we give you a JavaScript, we give you a JavaScript that gets added to the browser. The JavaScript then submits the credit card information direct to the payment gateway. And then the payment gateway responds back with a token that represents a credit card, but it's not a credit card. It's a one-time use credit number. And then that's the one that gets submitted to you on the server. And then you charge to that token. It's a one-time use token. No one can use that besides you because now you're also signing that request, right? So this is a tokenization process. And if you use that, now you're not touching the credit card information. The credit card information goes straight from the browser, straight to the payment gateway. So you're PCI compliant at that point. All right, so we talked about the transaction security. We talked about the tokenizations. Now let's talk about some of the things that you can do to protect you from the fraud. The easiest way is to use a velocity check. And the velocity check, even if it's a big word, all you're doing is looking for a customer behavior that can be suspicious. So most of the fraud can be detected if you just look more closely. For example, if a customer orders same thing 3 times in 5 minutes, you would know that could be a fraud there, right? If a customer is ordering $1,000 item 3 times a month, there's probably something going on there. And or you look at the minimum and maximum. Typical order is $50, but someone orders $600 worth of merchandise. There could be a fraud there. So these are the velocity checks. So we offer some of the velocity checks with the payment provider, and you may want to check with your payment provider if they offer velocity checks. Some of the checks are given are also available in e-commerce shopping carts, for example. But most of the time, you want to customize your website, customize your business to look for the behavior, look for the payments, and make sure that just looking at the behavior, you'll find out what the fraud looks like. We do that automated within MasterCard. So MasterCard, we look at more than just your merchant. So we can look at across and say, this credit card is used by this merchant, this merchant, this merchant in the last 5 minutes. What's going on? And so we do that on a system basis, and we may decline those transactions or have you for more scrutiny. But it's an easy way. It's built-in way within the network to use to detect fraud. Last but not least is the ABS CVC checks. It's a burden to ask for more information from the customer. I get that. But ABS is address verification service, and the card verification code is CVC. These are these 3-digit, 4-digit codes that are available on your card, front or the back of the card. Just asking that information reduces the fraud significantly. These are given by the issuer. So if you look at that diagram, that we had in the, maybe it's here. The CVC and the ABS checks are carried out by the issuing bank. So the issuing bank, when you're sending a data about ABS checks, it doesn't really deny the application, but it says that, hey, your ABS check was wrong. And based upon, if you want to carry out the transaction, you can carry out the transaction, or you can approve the transaction, or you may want to ask the customer that, hey, you failed the billing address check. What's going on? And have them probably correct it. Deny the transaction and correct it. But ABS check is the most basic way. ABS or CVC check is the most basic way that you can protect yourself from fraud. So we talked about four different ways: transaction security, tokenization, velocity checks, ABS, CVC checks. These are the basic mechanisms that should be available from your payment provider. So check them out. It's Simplify Commerce, again, it's a product of MasterCard. We offer all these checks. Right now, I think we have 10K free in transaction volume for all the WooCommerce attendees here. It's instant acceptance, 2-day funding, and it's built by MasterCard. We know payments. So get started. Any questions?
Do you know of a solution for WooCommerce that works for pre-authorization, then charging the client, like maybe after a service has been rendered?
So we offer APIs and SDKs. So we are a developer platform, so we offer SDKs in 9 different languages, and we have the API that would do the pre-authorization. We are in Simplify, we are in WooCommerce 2.2 core now, but I don't think that we have implemented. So WooCommerce guys, implement the pre-auth. We have the API available. I'm sorry? Yeah, so we have a subscription API. It's, you basically charge per month. It's a plan. You can have different plan. Again, we are awaiting someone to write a plugin for subscriptions. Go ahead.
Curious what differentiates you guys from Stripe?
That's a question that has been asked a lot of times. We are different in the sense of we are MasterCard. We are available in 210 countries. We transact in 150 currencies today. We are a global company. So, hope that answers that question.
Yeah, I have 2 questions. One is, do you guys have a pre-order system in place?
Yes. So the pre-order is where you're doing authorization, and then you do actually capture that payment later on after you ship the product. Yes, we do.
Okay. Number 2 is, I essentially manage 2 sites that sell pretty expensive products and services. We see pretty high transaction failure rate, largely due to what you referred to as the CPC and AVS, but I think mostly because of the price points of the products. Are there any steps we can take to implement certain pieces to mitigate that in some way?
Yeah, so the AVS CVC check is probably the best way. Unfortunately, it's not available in all the countries, right? So AVS check is limited to Europe and US because there are no zip codes filed, for example, in Ireland. But wherever it's available, use it. There are different codes that come back from AVS CVC checks. There are like 20 codes that come back based on whether it's actually a failed check or whether it's not available. So there are different reasons why those cards get declined. You have total control over what those check, what that means. And you as a merchant decides whether you want to carry out the transaction, because ultimately you are taking the risk for a chargeback, right? My suggestion would be to go back and look at where the transaction came from. If it came from a country that doesn't have AVS CVC checks, most of the Asia doesn't, you may want to just verify that that's a real customer. But there's no magic bullet for that.
Well, with our current gateway, you really don't get much feedback other than whether or not the address was verified, the CVC was verified, and then after that, if it fails, it's just...
Yeah, so we also try to make it simple. I mean, this is a right balance between how much information that we want to give you and how much information we want to confuse you guys. So we have a simple way to say, if AVS check fails, then reject the transaction or decline the transaction. What that does, though, is instead of, we don't keep the authorization, because typically what happens is if you don't actually capture that authorization, the authorization stays. So the next time the customer gets pissed off because customer now has authorization on the card for which actually you decline the order. So what we do on our side is we actually send back a response to the issuing bank that, hey, remove that transaction. So it's a balance, really. We can, so we have information available. It's how much you want to act on. It's up to you.
Cool, thank you. That's about all the time we have for questions. Round of applause for Rahul.
Thanks, guys.
Thank you very much.